concept is what is known as k nearest number algorithm. Let's take k equal to 1. Let's say you have one new point that has, you have a new point that has come in. What you do is you try to identify the nearest point to that, see what class it belongs to, and then assign that to the same class, assign the new point to the same class. If you generalize that one neighbor to k neighbors, you can take distance of that to all the points and find out k nearest points to you, find out the class labels of them, find out the majority label, and then assign to this particular variable that particular class. In case of regression, you could be like calculate the average of the values of the output of the k neighbors. Yeah, I think so. I think it's a good thing for streaming neighbor. Definitely. So why is this done like this? Because here, if we were to do this across the entire sample instead of nearest neighbors, it would cause massive distortion to the truth. So the idea is basically that you are most similar to your neighbor. Your behavior is very similar to your neighbors. So that basically gives us a very different class of algorithms. So you see example here, one nearest neighbor. You look at the circle, the one which is closest, you look at that. Similarly, if you look at two nearest neighbor, you look at this. Three nearest neighbor, you look at this. Probably in this case, you'll give a plus. Based on this, we usually create what is known as a Voronoi diagram, which is basically, if you want to plot all the points belonging to what is the class of this initial point, this will be the segregated point, which is basically it is the idea that all the points closest to that point are mapped in this. If the moment you move from one partition to the other, the closest point becomes the next vertices. Voronoi diagrams are very interesting way of capturing the symbol, what you call visually this. So what is it we're doing here? We are not creating any model. We're not creating any model. We are creating a just-in-time assignment of class or function based on the random as data as it comes and doing a dynamic understanding of which are the nearest neighbors, looking at the data corresponding to it and trying to get that. Now we will go to Weka. Let's open Weka. We will go through these key algorithms which are basically decision tree, random forest and KNN. Let's explore. Let's open the iris dataset. If you look at iris dataset, we have already run things like linear classifier. Sorry, we've done clustering earlier. Later, we've done classifiers on this, Bayesian classifier. Now, let us go to trees. Let's look at J48. J48 is the decision tree algorithm, which is basically complex in the sense it allows for backtracking. It does a lot more improvements over original ID3 algorithm. Let's do percentage split. Let's say 80-20, and let's start. Wow, this is amazing. This is saying that I have probably nearly perfect classification because my decision by confusion matrix is showing nothing misclassified in the test vector. Could you get this? Could you run J48 on iris data with 80%? Now let's look at what is the tree that is generated. Let's go up a little bit. This is the tree. It says that if petal length is less than 0.6, then straight away it is iris centosa. If petal length is greater than 0.6, then next level we look at petal length less than or equal to 1.7. Then you go to petal length. Then you go to next petal length greater than, then you go to petal width again. So if you see here, we may be visiting petal width in finer granularity, same variable at the lower node, because earlier it was just saying greater than 0.6, right, at that branch. At the lower where you're saying greater than 1.7, and you're also working with less than 1.5 and greater than 1.5. So it is important for you to visualize this tree. So what I'll do is go to right click on the left side. You can say I want to visualize tree. You see this, it may not, because it is saying that the data is actually not requiring to use other attributes. There's no variation in the other attribute. That's what it is saying. You can try experimenting if we want to do, I don't know, if you do cross validation, will it give something else? I don't know. Yeah, I think what is happening is because of the pruning, which is basically backtracking, and this it is removing those branches which are not adding value. Otherwise, it was original. Let us see if I have the original algorithm here, which is simple card. So idea is, I think that it's very clear that the sepal is not playing much role. It is getting subdued because of the. Now, what you may want to do is, you see that when you're doing cross validation J48, this is the rule that is coming up. Now you want to visualize the tree. As I said, you can go to right click and visualize the tree here. This should give you an idea of how trees are different from the straight lines, which is usually the common thing in linear classifiers. Now on the same sample, let us run random forest, which is, as I said, right? Random forest, let us look at the error here. In case of root square relative absolute error, it was 8.85%. In case of J48, it was 7.87. That's okay. So this is something which didn't improve much. Let us try some other file. Let's say we try working with diabetes and go to random forest. It's pretty high. So I'm just trying different models. You see what I'm doing? I'm trying random forest, I'm trying linear classifier, I'm trying multi-layer perceptron. So for the same sample, I've tried different ones. If I see here, I find that neural nets probably have given the best results here. Let's see if I can choose logistic regression in this case. Marginally better than others. So what I'm doing is I'm doing iteration between different instances. So is this clear? Decision tree, random forest, and how it is yet another paradigm complementing the paradigms which you have learned till now. So for the same example, I have run logistic regression, I have run neural net, I have run J48, I have run random forest. Think about it. So what am I doing here? I'm trying to evaluate the potential for different combinations of this. Now